To protect citizens from harmful exposure to ionizing radiation, European research aims at improving understanding of the effects of radiation. Radiation protection is a key consideration in all uses of nuclear technologies, including in the area of medical diagnosis and therapy. But what are the effects of ionizing radiation on the human body? In particular, more research is required on the risks of low and protracted doses of radiation. Critical is our understanding of the mechanisms involved in our DNA, our cells, our tissues and our entire body when they receive low doses of radiation.
The only knowledge that we have are extrapolation. And the main difficulties is that we are dealing with effects that are not really detectable just after the exposure on the individual, but that will occur maybe 10 or 20 years after the exposure.
The human body's response to radiation differs from one person to the next. What are the mechanisms involved? Who are those most at risk? To answer these fundamental questions, more research is needed. The vast majority of a typical person's yearly exposure is from naturally occurring radiation. For example, from natural radioactive material in the Earth or from cosmic radiation. However, there is an ever-increasing exposure resulting from medical applications such as diagnostic imaging and therapy, for example in the treatment of cancer. For some of us, the level of exposure can be significant. Every year, some 430,000 cases of breast cancer are diagnosed in Europe, of which 130,000 prove fatal. Earlier detection using improved diagnostic imaging techniques are an important weapon in our battle to reduce the mortality rate. Mammographies using standard X-ray techniques are today considered to be the state-of-the-art in the detection of breast cancer. Improved imaging can be achieved using computed tomography. In Nuremberg, at the Institute of Medical Physics, new methods of diagnostic imaging will be developed. Professor Willy Kalender has dedicated his life and work to the field of CT. Currently, he's working on research aimed at developing dedicated breast CT for women.
We can have what is in novel terms a one-stop shopping thing that we are aiming for. And I think that is very patient-friendly again here. In any case, as the breast is under the table, the source and the detector will rotate under the table, so the woman, the patient, doesn't see that, and we take the data that way. So it is CT, but only CT of one body part, not of the whole body.
His research is not only aiming towards a better quality of diagnostic imaging, but also at reducing the dose of radiation during the breast CT imaging.
In most cases, or practically all cases, we can limit it to below the natural background radiation dose level. For example, in this breast CT project, we want to stay below a dose of 2.4 millisievert.
This report has presented just a fraction of the research effort underway in Europe. In particular, the Euratom program aims to strengthen cooperation between member states and industry in all these fields for the benefit and welfare of European citizens. This research is essential if we are to develop technology solutions for a better future.